Welcome to my 14th class, 14th session, I would say. And this is the third class on forces and motion. So, continuing with our last class, which we did on friction, if you remember, we understood what is mu, and if this was a body of mass m, and if this was mu, and if this was a force, we found out that, and if this was F mu, we found out that F mu, that is max, would be equal to mu n, where n is the normal reaction and this is the weight acting downwards. So this is what we learnt in the last session. So now let us look at the scenario where now we have an inclined plane and we have a body of mass m again, and now this is inclined. The inclination is at an angle theta. So now let us understand how the frictional force will apply in this case. Again, let us assume that the coefficient of friction is mu between the two surfaces. Let me write. So this is mass m. So if you see, if this is mass m, what will happen is this body will experience a force of mg downwards. This is due to the acceleration due to gravity. And you will also see if mg is acting downwards, now what will happen is mg will have two components, if you see very carefully. So I'll draw the two components here. Let me use a different color for this. So mg will have one component along this direction and it will have one component along this direction. So if you see, by similarity of triangles, if this is theta, then this angle also will be theta. Therefore, this component will be mg cos theta, right? And this component will be mg sin theta. Please verify this from simple geometry. So basically what will happen is, as your angle increases, as it increases and it reaches a case where it becomes 90 degrees, what will happen is, let me draw a limiting case. If this is, and this is your box, so what will happen is you will have mg acting downwards like this, and you will have one component here and you will have one component here. So if this is theta, then this becomes theta, and at a limiting case at theta is equal to 90 degrees, what will happen is cos theta will be equal to 0, right? Therefore you understand that it will have no normal reaction. Now let us understand, let us apply what we learnt in our last class. What we learnt is force is equal to mu n. This is frictional force. Now if you see, what is the normal reaction? Obviously normal reaction will be in this direction, correct? And we see that normal reaction in this case is n is equal to mg cos theta. You can see it very clearly here. And therefore, what is the maximum force? What is the maximum frictional force that is exerted in this particular scenario? F mu max will be equal to mu n, and that will be equal to mu mg cos theta. Clear? Now understand one thing. Now as you see, now as I keep increasing this, if I keep increasing this inclination, initially the body won't move, but at a particular theta the body will slide down. And when it will slide down, it will slide down when the frictional force, or rather when mg sine theta, that is the force that is acting, the force of the body due to gravity that is trying to slide it downwards, becomes equal to the maximum frictional force, right? Because the maximum frictional force that we calculated is so much. And in which direction it is acting? It is trying to resist the motion here. So this frictional force is definitely acting in the opposite direction, and it is mu mg cos theta. So at a limiting case, when you increase the angle here, at some theta the body starts sliding downwards. And when that will happen? That will happen exactly when mg sine theta is equal to mu mg cos theta. Therefore mu will be equal to mg sine theta by mg cos theta, and this is nothing but equal to tan theta. Therefore we see which is mu. This is a very important relationship. Now if you see this relationship, you are able to find out mu, the value of mu, just by understanding, or just by knowing at what angle of inclination the body will start sliding down. Therefore you see, mu does not depend, the value of mu is independent of the mass. It is also independent of the area in contact. This is a very important relationship, please understand. So just by calculating the angle at which a particular body starts sliding down, you will be able to compute the mu of this surface. So for example, if I take a plane and I want to find out the coefficient of friction, I take a body, then I slowly start raising it. I'll raise it at this angle, then I'll raise it at this angle, then I raise it at this angle, and at the angle at which it starts sliding down, I just record that. So let us say if this is, for example, 45 degrees, then mu will be equal to tan 45. So please understand this concept. It's a very, very important concept which we will use further as we keep solving more problems on friction. So I'll see you in the next class where we'll discuss problems on friction, but we will also try to understand the concept of a free body. Concept of creating or drawing a free body diagram. I'll discuss this in the next class. Free body diagram is nothing but when I take a body, let us say this is a body lying here. So if I have to draw the free body diagram of it, I isolate the body from all its surfaces and just draw the forces. For example, if this is mass m and a body is lying on the surface here, if I have to draw the FBD, it's also called the free body diagram, FBD. So what will I get? I will get two forces, normal reaction, and this is mg. So this is the free body diagram, free body diagram of this in this particular case. So we'll discuss more on this in the next class, and we'll also try to derive some equations along the way. So I'll see you in the next class. Thank you.